So that you know, we are recording. So again, this is in the class notebook. Make sure you have those highlighters ready. So I'm going to start by putting my name on here. Always. We're going to talk about congruence and transformations. So last week we learned or relearned, right? We revisited our 3 rigid transformations or rigid motions. And those, of course, were translation, where we go sideways, up and down. Reflections, where we were flipping things this way and over lines. And the rotations, where we were spinning things either counterclockwise or clockwise. So we touched on this last week as well. You can do a combination of those, and because they don't change the size or shape, then they preserve congruence. So for this part, 4.4 of this lesson, our lesson objective is I will be able to identify congruent figures, and describe congruence transformations. Sometimes you may have figured out there's more than one way to get from one space to another. So congruent figures, 2 geometric figures are congruent if and only if, remember that means both ways, there is a rigid motion. Or, and this is again what we talked about last week, composition of rigid motions. That maps one of the figures onto the other. Exactly, right? It has to be perfect and exact. So the size and the shape has to be exactly the same, even if the orientation isn't. So these 3 shapes are all congruent because they have the same size and shape, but these are not because they don't have the same size or shape. Okay, and remember the rigid motions we discussed are section 1. We talked about translations. Section 2 was symmetry, and so we were reflecting things. Section 3 was where we were spinning things, so that is rotation. The rigid motions are translation, reflection, and rotation. Yeah. Any questions so far? You know, also feel free to pop your hand up in the chat for the meeting. I can see that too. You can identify congruent figures in the coordinate plane by identifying the rigid motion or composition of rigid motions that maps one onto the other. So it seems a little repetitive, but this example here has congruent figures in the plane. There's a one of each. So we're going to find pairs. There's 3 pairs where one is a rotation, one is a translation, and one is a reflection. And this is where my colors are going to come in. And so I'm going to go first. First one I'm going to do is the squares. They look the same to me. So I'm going to highlight these squares, A, B, C, D, and I'm going to be able to move that square to this one. Or I could do it the other way around. Because there's no marks, there's no image and pre-image here. Right? So you can either go up and over to the right, Or if you're going this way, you could go left and down, or down and left, or right and up. See, so you can do it a number of different ways, but that's a translation. So my first one is going to be translation. And so this is what we're going to do. I'm going to write down that I'm just going to put a little square mark in there. Okay, for A, B, C, D is congruent, says identify, to triangle. A starts here, B, C, D, so N, P, Q, R. Got to go the same direction. N, P, Q, R. So they are congruent. Now, I know it's kind of hard to see unless you've printed this out, but how would you describe the translation to get from here to here? From here to here. Like, what's the rule? How does this map onto that? How many units do I have to move over to get even with this other one? How many units? Don't be shy. Zaina, can you count? Can you see it?
Yeah, I can see it.
How many units are you going to the left?
To the left, you're going 1. Oh, sorry, 2.
Yes, 2, because I would take it directly above it. So remember to write the rule. We're going to do -2 because you're going in the negative direction. Sophie, how many units would I have to move down? If I'm here, how many do I have to move down to get to here?
Three. Would it be 4 or?
So yeah, 4 would put it right here. You actually want to go 2 more. So, and one way you can count is this. Your C would be up here. So then you'd put your C here up in the top corner. So it'd be 1, 2, 3, 4, 5, 6. Although I wanted to say 4 also when I started. So that'd be 6 down. Any questions on that? Okay, now just out of curiosity, if you did want to go from here to here, then instead we would go up 6, right? And +2. So if you wanted to write it the other way, it'd be x +2 and y +6. You would just have to say which one you're starting at and which one you're ending it at. So that's all good. Okay. Does anyone see another pair that I can do a transformation with? Clearly they're triangles. Which triangles are going to match up? And how? Okay. Seems like you're all shy today. Okay, so these two are congruent. See, I've used my pink to match them up. How did we match those two up? So this is FGE congruent to LMK. And what transformation could take you from here to here. You all did this really well last week, so was it just a long weekend? Speak up.
It's a reflection across the x-axis.
It is a reflection across the x-axis. So hopefully everybody can see this line here, right? So if you just take this and flip it over, reflection, and we say in the x-axis. If I were going to write a rule, right, all that changed was my x's are still the same, but the y's turned negative. So if you were going to write that rule, it would look like this. My x's are the same, but my y's are negative. That's reflection. So then the last two, hopefully you're picking up on this when I said there's, you know, one of each. So this purple one is what kind of transformation? This is triangle IGH. I's there, TUS, I think. So what did I do to this triangle here to get all the way over here? There's actually a number of answers. So if you think of one, somebody else will think of the other. What's one way to get this over here? Do you want me to call on you again? Giselle, what's one thing that comes to your mind?
I don't really know.
Okay, so it seems like I have to help a little bit more, which is fine. There's two different ways you can do this. And I'll start with this way. Doesn't it look like a rotation? So if I start here and I turn my paper all the way around 180 degrees, it looks the same. So that means you're mapping it onto itself. Or here's the thing with 180, say I went this way instead. I went clockwise because that's counterclockwise. So say I went clockwise. Doesn't that still look exactly the same? Yes? So one of the things that you can do to get those triangles is you can do a 180 rotation. Now it doesn't matter in a 180 whether you go counterclockwise or clockwise, but you do have to say where the center is. So the center is the origin. If you do say rotation, you have to say about the origin. You always have to say where the center is. So if you had your pencil here and spun your paper around, that's your middle point. Did anybody think of another way to possibly get the purple to the purple? Erase this while you're thinking. This is think time. Now that we've done these transformations, you'll have to come up with more. Okay, so I don't know if anybody remembers this from last week, but remember we were rotating, I'm reflecting over y equals x. So this is another example where this one is exactly the same distance from here on the other side and it's flipped. So you actually could do a reflection in y equals x. So that's another way you can think of it, is flipping from here to here. All right, any questions so far? You guys are so quiet today. Okay, so we're going to do another example, and this is going to be even harder simply because there's more than one way to do it. And again, I'm going to ask you for your input. So a congruence transformation is another name for a rigid motion or combination of rigid motions where the pre-image and the image are congruent. So it's just another name. It's like vocabulary that we can use interchangeably. And so what I'm going to ask you to do is look at these two figures, and I'm going to ask you describe a congruence transformation. So like figure out what you could do to, we're going to take this one and we're going to map it onto this one. So again, you don't have to write the word quadrilateral. You can just put that little symbol, A, B, C, D, and the little symbol E, F, G, H. So this is our pre-image. And this is our image. And so this is where I want you to put on your thinking caps and try to figure out, how can I get from here to here? What series of transformations could you do? In other words, there's more than one. So anything you can think of here. Could you do a rotation, a translation, a reflection, or both, or two translations, or two reflections, any combination? Well, do I have any volunteers? Anybody who thinks maybe they could do the first one and I'll do the second one? How are you going to move this one over here? Normally, you guys are much more chatty. Am I stumping you? Is that it? All right, so I'll give you an example. And this is exactly why we're going to do more practice problems. Let's say I take this quadrilateral and I just move it down so it's on the same level as this one. Okay, so this one is 1, 2, 3, 4 units down. So what if I just move it 4 units down? I'll start there. So like this would be A prime, G prime, B prime, and C prime. So then the next question would be, you know, how could I turn this one into this one? So, you know, for example, so let's see, my first transformation would be a translation 4 units down. So that rule would just be y minus 4. So how do I get from green to over here? Like almost ignore this here. How do those look related? I know somebody knows a relationship here. I just am not seeing any hands.
It's a reflection.
It is a reflection. Thank you for who spoke up. And it's a reflection across what?
The y-axis.
I guess you should say in, reflection in the y-axis. So if this flips over the y-axis, then it matches exactly. So it would match it. So the reflection in the y-axis, all these points are the same, except they're all, the x's are negative, but the y's are all the same. So the x's are negative, but the y's are the same. So if you started with this one, and you changed it, then it would be negative x, y minus 4. So this one rule right here, oops, let's see, I'll use this. This one rule, because we combine those two, would be a congruence transformation, because it would take you from the first one up here to the second one. These would map exactly. But we use two transformations, which is why it's called a composition or a congruence transformation. So we're going to practice these. Just another couple of answers might be, you could have reflected this down and then reflected again, 2 reflections, or you could shift this back with the translation and then reflect over. You could have done a rotation, but those are harder. There's a number of different ways to do this, and so that's why I want to make sure that everybody sees these are harder. We do need to practice because of that very reason. So what I'm going to ask you to do is keep these notes with you. Now, there are 2 theorems in section 4.4. We're going to go over those tomorrow, like how to use the theorems. Today's just identify. Okay, so if you do want to see those theorems, they are on page 109. Your practice right now is I'd like you to do numbers 1, 2, and 3 with exactly these things. Just identify congruent figures and say why. Describe a transformation that goes from here to here, and then describe another one that goes from here to here. So that's going to be your practice. There's lots of different answers. And then you're going to attach this, of course, in T. So any specific questions right now? I need to stop. I'm going to stop the recording.